Thank you very much, Priyakshi, for organizing this webinar on India's battery material space roadmap to customer qualification. I believe this is, I think, the best time to have such conversations, and that too when we have such amazing panel members. And I think we are going to have very exciting panel discussion followed by a presentation by Venkat. So in my presentation, in next 20 minutes, what I'm going to talk about is why it is very important to focus currently on the LIB manufacturing in India. And other than, I think, focusing on any other part of the ecosystem, this part of the ecosystem becomes most crucial at this point in time. Then I'll talk briefly about the overview of LIB battery in India, what kind of battery chemistries are being researched or being manufactured in India, or at least being planned to be manufactured in India, and then the current battery supply chain in India. And in the end, we have some certain recommendation also, which can be utilized by different stakeholders. To begin with, as I talk about why the policy related to PLI, related to advanced chemistry cell or cell manufacturing is most important in India, is that we have other policies like FAME or the phased manufacturing program, which has been running, which has mixed responses, which has enabled industry development in certain way. But I think until or unless we have a very much localized battery manufacturing in India, the real objectives of energy security, manufacturing import dependence, and carbon emissions, we are not going to meet. So as very encouraging step, PLI ACC has been rolled out despite a lot of questions. I think Randhir ji will be very happy to see the developments because it all happened during his tenure. So Rajesh Exports, Ola Electric Mobility, Reliance, New Energy Solar now are building around 30 gigawatt hour of battery capacity in India. And if you look at during the scheme, there were other players, which some of representatives are present today also as part of the panelists. The latest development is that these companies has been progressing, which were allocated these 30 gigawatt hour of manufacturing, and the commercial production is anticipated to commence by the end of financial year, fiscal year 2024. And so there is a lot of progress. Now let's talk about the entire overview of the battery industry in India. I'll here only talk about the estimated numbers, which are around more than 100 gigawatt hour by 2030 in one of these scenarios predicted by Niti Aayog. So with such kind of demand, what kind of batteries chemistries we are expecting? If we currently talk about what battery chemistries we have, we are mostly on the LFP and NMC battery chemistry. If I talk about segment-wise applications, let's say for two-wheelers, it is more inclined towards NMC chemistry. For passenger cars, because of the dominance of Tata Motors, it's mostly LFP chemistry. In three-wheelers, if you talk about e-rickshaws, it's a different chemistry, but upcoming L5 segment probably is going to have on at least 50-60% on NMC chemistry. In buses, again, we have NMC chemistry, LFP chemistry as a dominating chemistry, but there are manufacturers which are working on the NMC chemistry as well. Around 2030 or 2035 as a speculative outlook, the things are going to be changed because there are different battery chemistries being worked on. So there is a possibility of introduction of semi-solid state batteries, solid state batteries, or any other different kind of battery chemistry also. It is very important to understand which battery chemistry makes more sense in India. And that is how the evolution of battery chemistry as well as adaptability of the battery chemistry is going to be done by manufacturers in India. So let's talk about the different cost constituents of LFP chemistry. So around 21% is contributed by cell cathode, followed by 15% by cell anode and others. At the same time, if we talk about NMC chemistry, cost contribution of cell cathode goes as high as 42%. And because theoretically, the localization possibility in NMC chemistry is lesser than LFP chemistry. So theoretically, it makes more sense to have LFP chemistry in India, given a lot of focus on the local value add. So theoretically, maximum localization, local value addition is possible around 69 to 90% in LFP chemistry, and maximum what we can achieve in NMC chemistry is around 43%. Based on these numbers, in terms of battery chemistry, what I just talked about, we have done some estimations in terms of different battery chemistries and the material requirement. So if you look at the left-hand side of the chart, you can see that nickel, cobalt, and manganese, and also lithium, iron, phosphate on the right-hand side of it. So if you look at the raw material like nickel demand for lithium-ion battery, which is expected to be around 15.9 kiloton by 2030 from around 0.6 kiloton at this point in time. And in 2026, you will see these numbers to be around 5 kiloton. So this is how the entire movement in terms of the material is going to happen in India. And because of the criticality of nickel, cobalt, and manganese, the momentum is going to be around too much, not actually too much increase because of the shift even in the battery chemistry, what we are in the NMC battery chemistry. So you will see the NMC chemistry share India, which is expected to either reduce or replaced by advanced NMC 811, which uses lesser nickel. Hence, demand of nickel, cobalt, manganese, and LIB are not likely to rise very exponentially by 2030. With LFP likely to be the major chemistry, iron as raw material would reach around 74 kilotons and phosphorus around 42 kilotons. Moving on, if you look at in terms of the anode raw material requirements, then anodes are basically the primary graphite based for LIB cells. And silicon doped graphite will improve efficiency are expected to increase share from current level of 30%. Silicon graphite anodes consumes lower quantity of graphite. So there is going to depend, because we have a very high estimation in terms of battery requirements in the mobility segment, the passenger mobility segment, electric mobility segment. So in turn, the material requirements are also high for both anode as well as the cathode. So given that we have a lot of requirement of materials, I talked only about two materials, anode and cathode, but is it like available in India? What is the raw material scenario currently in India? So if you look at the globally, whether it is a metal production or metal processing distribution, China has a dominance. Wherever they could not have the metal production distribution, they went ahead and they developed the capability around the metal processing part of it. So, and in this kind of a global scenario, India have to compete and find its own way to secure the material through whether production or the processing part of it. I'll not go into the detail of what kind of materials are available in India, but mostly India faces challenges across the materials which are being used in the lithium-ion battery manufacturing in India. One of the latest update is that Ministry of Mines in India has identified 30 critical materials that are essential for the country's economic and strategic security, and investments are now allowed in exploration. So there are three ways by which government is trying to secure the material, either have its own material or going outside India and invest in the discoveries which has already happened. And I think we cannot remove completely the import part of it. Now, if you look at the how India is approaching, so they have joint ventures with Kabil, which is Khanij Bidis Limited, created by Ministry of Mines. There are organizations like NALCO, HCL, MECL, they are into the exploration. There are different MOUs being signed with countries like Argentina and Australia. There were delegations, I think, in India of the countries which are very much interested in having collaboration with Indian government for the G2G collaboration to supply these critical materials. At the same time, we also have the discovery around lithium deposits. The famous one which came in the Jammu and Kashmir, and then there is one more discovery happened in the part of the Rajasthan. If all this becomes reality, India is going to be one of the top 5 lithium deposits, lithium reserves. And it is going to take, it's not going to become the reality, let's say within 2 to 3 years, but within 5-6 years, if it happens, it becomes the reality, it is going to help a lot in the entire overall battery manufacturing capability in India. So a few years back, we had very limited number of number of battery companies in India, but I think there are many more. We have included few indicative names here. And if you look at the investment in battery manufacturing is happening around by different type of players. So first is initiated by Government of India, which is PLI, in which I already talked about that 30 gigawatt hour is allocated. Now Rajesh, Ola and Reliance are building factories around it. At the same time, now we have the traditional battery manufacturers, which also has entered into the game, like Exide, Amara Raja, and their presence is going to strengthen it a lot. And then we have non-traditional battery manufacturers, right? Mahindra Group, Tata's, JBM's also coming up with certain level of capacity in India. And startup companies which are innovating, for example, companies like Signi, they also give a lot of hope. So there are 4 or 5 types of companies which are very active in this domain. So probably in terms of the announcements of battery capacity, we are going to see different kind of factories. Some of them are going to be mega scale, some are going to be on the smaller scale, but there is going to be mix of companies, which is a very positive sign for it. Now, if you look at the different value chain of this value chain of battery manufacturing in India, you have even at least there are announcements, investments, aggressive plans by Anode, Cathode, Electrolyte, and Separator manufacturers in India. I'll talk about the stage on which these companies are at this point in time. Then there are cell manufacturers, which there are companies which are working on the cell manufacturing, and obviously we already have the pack assembly manufacturers in India. So with this, if it becomes reality, the situations like this is going to change significantly in future, and we definitely are going to see some of the players from here coming as part of the list of the global manufacturing capacity. So now I come to the most interesting part of this talk, because the entire webinar today is focused on this. So whether we have manufacturers of anode, cathode, electrolyte, or separator in India or not, or what is the current stage of the industry, because until or unless these manufacturers are not there, cell manufacturing can definitely become a reality. But if it becomes a reality with very heavily dependency on imports, probably it's not really solving the objective. But yes, the good news is that across anode, cathode, electrolyte, and separator, there are companies which are exploring the opportunity and coming up with the investments. Now I'll briefly talk about the status of anode manufacturing in India. As all of us know that Epsilon, Himadri, and HEG are very actively working in this domain. Let me briefly talk about the key considerations for anode manufacturing in India. First is approval from the global battery manufacturers. So potential anode manufacturers in India, they basically initially try to get approval from global supplier, mainly, because of the scale. Once they become the supplier for global players, they will get surety in terms of the demand of the anode material which they are producing. As global players enter new geographies, they will definitely bring such suppliers. So investments first outside India, in case they don't find scale in India, is really important. Second key consideration which we have thought about is exports to lead demand. Anode manufacturers in India are making plans for manufacturing based on global scenario, not only India scenario. India lacks on two fronts, right? One is the proximity to the resources, and second is the surety in terms of the demand, because we don't have any quantitative targets by what time India is going to convert to how much across the vehicle segment. Then the domestic demand for local cell manufacturing companies is expected to be take at least 2-3 years from now. As the trend in other industries are there, Indian anode manufacturers can be favorable. Every OEM is looking for China +1 policy. So there is a very high chance for anode manufacturers in India. And obviously, if it is competitively priced. On the right-hand side, you can see the different plans and recent updates by companies like Epsilon. For example, Epsilon has produces Mesocoke 2,500 TPA capacity, pilot facility of synthetic and natural carbon, synthetic anode production of 100,000 MT, and natural anode production of 50,000 MT by 2030 has been announced, and investments has been made outside India. Now I'll move on the status of cathode manufacturing in India. If I compare with anode manufacturing status as well as the cathode manufacturing status, probably India is in an advanced stage of anode manufacturing. Cathode manufacturing is going to take a little more time because of the several challenges which India offers, and there are some of them are legacy challenges as well. For example, lack of clarity on demand. Now it is becoming a little more clear that which company is going to work on what kind of battery chemistry. I also talked about the estimations which we have done, but still there is unclarity in terms of which battery chemistry or what are the major battery chemistries India is going to have in future. So until or unless these battery chemistries are fixed, it becomes very difficult for anode manufacturers because it's different for different battery chemistry. Lack of government push and scheme. Now, when India decided to push for the battery manufacturing in India, entire push was on the battery manufacturing, and the considerations about upstream supply chain like anode, cathode, separator, electrolyte manufacturing, it's really the game between the suppliers as well as the battery manufacturers. So none of these policies are focusing on cathode manufacturing in India. Incentives are being provided to the cell manufacturers. So because anode and cathode manufacturing requires huge amount of investments, there is a requirement either at the state level or the central level or in any part of the policy making consideration for the push by giving incentives for the anode and cathode manufacturing also. The other challenge is lack of technical expertise, availability of raw materials. Now, cathode manufacturing has not been happening in India. So there is a very, very limited capability in terms of overall expertise of manufacturing, availability of talent pool, experienced organizations. So that also becomes a very big challenge. But yes, there are companies like Alox, BSF, Altimin. Some of them are present here today, so we will hear out them. For example, Alox has a patented technology to create cathode and plans commercial production in 2023 with 10 to 15 tons per day. There are a lot of challenges, but in terms of the clarity of the targets, they have it. I'll also talk about BASF basically has a different battery chemistry. So whether this company will find its way to India directly manufacturing, or they realize they're one of the global bases, is not very clear. But yes, there is a high potential that companies like BASF can play a major role in India. In terms of Altimin, they and ARCI have partnered to begin production of cathode materials for lithium-ion batteries in India. The organizations are planning to set up a pilot plant in Hyderabad with the capacity of 100 kilograms per day. Moving on, I'll talk about electrolyte manufacturing in India for the LIB cells. So these are very early stages of electrolyte manufacturing, but there is a growing interest from both domestic as well as the international players. Let me talk about the availability of different raw materials for the electrolyte manufacturing: salt, solvent, and additives. Salts from manufacturing electrolyte is locally available in India. Procuring the salt from local players may be a challenge due to local competition. In terms of solvent, there are solvents like EC, EMC, DMC. They are not locally produced in India and will have to be imported. Only commercial grade solvents are available in India. In terms of additives, they are also difficult to be manufactured locally and hence will have to be imported too. Even if we develop the manufacturing capability for electrolyte, we are going to have a certain level of import dependency. So if you look at the electrolyte supply chain in India, technology, raw materials, processing, and sales, there are organizations which are active in this domain. Moving on, briefly talking about the separator manufacturing in India. As you know, cell manufacturing is growing in India. The demand of separators will also definitely increase as other components. And it is also very, very important to meet that 60% value addition as part of the PLI scheme. And any other organization, even if they are not part of the PLI scheme, would like to have a certain level of value addition to be competitive in the market, because price eventually also plays a big role. So the key considerations for separator manufacturers are long-term demand contract, raw material supply impact of cell chemistry, wet versus dry processes of the separators. And companies like Neogen, Duramic, Entech have their own plans and recent updates, which you can see on the right-hand side of the presentation. For example, Neogen is planning to set up a manufacturing capacity of around 1,200 to 2,400 tons per day. They also claims to provide electrolyte samples to cell manufacturers and a capacity of 250 metric tons for pilot testing. Similar announcements are by Duramic and Entech as well. But definitely these things, the separator manufacturing is definitely going to take some time before it becomes reality. But until or unless anode, cathode, separator, and electrolyte are manufactured in India, India still will have to depend on imports, which eventually has to be removed as much as possible. So these are the status. Recently, we did a study with ASSOCHAM, and some part of the recommendation from that study I would like to talk here is that in terms of effectiveness of PLI scheme, so the current PLI for SCC will definitely help developing battery manufacturing capability in India. But government should also try to include smaller players. Obviously, there is a logic behind not including smaller players, but if there is a possibility, it has to be done. The current scheme mostly focuses on the local cell manufacturing. It does not focuses on the material manufacturing, which I talked about. So if there is a PLI scheme which introduces the other part of the value chain, mostly around the battery material supply, is going to be very useful to develop overall ecosystem in India, which eventually is definitely very, very important to make sense of movement towards electrification. Then there are some recommendations for EV supply chain and export potential, PLI for materials, as I mentioned in the beginning, and then focus on exports in other part of the world like Southeast Asia, LATAM, and MENA. And R&D investments are missing. In FAME 1, there were supports for R&D, budgets were allocated for R&D, but in FAME 2, we could not see that. So when FAME 3 comes, or as part of any other scheme, government should try to focus on incentivizing R&D or funding R&D also. That's all from my side. I'll be present during the webinar, so I'm open for any kind of questions. Thanks, Priyakshi.